tons of different training events. We also have Lisa Klaus here, who's on our team, and we have Debbie Bard, who is I think our boss's boss now. Um, and you're going to hear from Debbie in a moment. She's going to give our first presentation. So lots of NERSC staff. Please feel free to talk to all of us, ask us lots of questions. Um, and yeah, we'll be happy to help you out during this training. Okay, let's go ahead and jump into our little welcome activity. So this is just to get to know who's in the room. So let's get started. All right. So we'd love to know a little bit about the scientific research projects that you're all working on. So if you want to type in a couple words that describe your scientific research, maybe what field, maybe if you're using a specific application like a code, what kind of data are you collecting? Anything that relates to your scientific research that gives us an idea of what are you working on this summer? Ooh, virtual reality. Density functional theory, excellent. E3SM, snow. Ooh. The funny thing with sometimes when you're working with different computer applications, sometimes things are called one thing and they do something totally different. So my first instinct was, is snow actually means snow, or maybe it means something else? Quantum computing, wow, lots of quantum computing this summer. That's awesome. Great. Very cool. Okay, seeing lots of different things. Transcriptomics. Okay, someone will have to explain to me what that is. Great, thanks everybody. Um, would love to hear, where are you joining us from? So you can tell us where you're from, whatever you consider home. You can tell us where you're joining from. You can, whatever kind of answers this question for you. Where are you from? Jamaica, Brazil, Los Angeles. All right. Ooh, Berkeley, of course. Building 59, yes.
But Lippy, do you have a link to the or oh no, it's showing on the
Yeah, on
so
the
a
very
couple of
top.
users. If you want to join Mentimeter, just go to menti.com and enter the appropriate code.
And actually, I can. That's the link right there. So if you're in the chat, you can use that link I just posted.
Awesome.
Great. Madison, Baltimore, USA. Building 92. Great. Blue shuttles. Nice. Great. Wonderful. I always try to look and see well, it depends. Sometimes people are saying where they're from versus where they're joining from, but I see Tokyo. I see Turkey. Very nice. Excellent. Thank you. Great. Okay, so this is just to get a sense again of where you are in terms of your high performance computing journey. So, just how do you're this is kind of hard to quantify, but do you agree with these statements? Do you disagree with these statements? How are you feeling? Are you new? Um, you know, we're trying to see, do people tend to think this is something that's going to be really difficult and hard to use? Um, And then, do you think that this is a useful skill? Is this worth spending your time learning? Okay, so in general, mostly kind of 50-50 in terms of people are new. Um, Good. I'm glad to see people don't think it's super difficult and hard to use. And people generally think that this is a useful skill, so that's fantastic. And going into today's session, how are you feeling? Are you feeling excited? Are you feeling nervous? You can be excited and nervous. You could be not excited and nervous. You could be excited and not nervous. Oops, what happened? I think I did something wrong. Okay, good. Nice. Good. Okay, so not too many people feeling super nervous. Couple people, and that's okay. Not too many. Yeah, you're neutral about feeling neutral. That's great. And people are feeling excited. That's awesome. So we're hoping to see people feeling more excited and less nervous after the training event ends on Friday, hopefully. Even by the end of today, I think you'll be feeling much more confident. So that's excellent. All right, thanks everybody. I hope you are awake. And I will stop sharing. Charles, do you want to kick us off with the rest of today?
Yeah, sure. So, hi everyone. We want to welcome you all to our new user training and best practices on Perlmutter. My name is Charles Lively, and as Lippy mentioned, we are science engagement engineers, and our basic job is to create a community of practice and to work with our users, engage with you, and allow for you to take the most advantage of the resources that we have at NERSC in the most efficient way possible. So if you ever encounter any questions or problems or concerns, we always encourage you to submit a ticket or even, you can book in a live office hour appointment or, feel free to reach out to us. You get plenty of emails from us, so you know where to reach us. And starting today, we will have our division director, Dr. Deborah Bard, give the introduction and welcome to NERSC. And also, again, we have on the line our counterparts, Helen He, as well as Lisa Klaus. And I will allow for Helen and Lisa to introduce themselves before we have Debbie kick things off.
Sure. My name is Helen He. I'm also in the user engagement group and I do a lot of user training. Welcome to NERSC, you're new users now, but from now on, please, you'll see lots of training events opportunities. Do jump into them and hope you learn a lot and do lots of science, good science on Perlmutter and future NERSC machine, NERSC 10 Doubtnut as well. As Charles mentioned, feel free to send any questions to us, consult at nersc.gov. And also we'll have weekly office hours during summer from June to August. So you'll see those announcements in weekly emails. And I think next one is 1 week from now. So any questions, you get live help. Well,
And I can't stress enough, the benefit of being able to attend an office hour and get any questions you have about using our systems answered by many of the amazing experts that we have in NERSC. When I was a grad student, I wish something like this was available. So I encourage you all to please, please take advantage of it. No question is too small or dumb or anything. Our goal is to help you make the most of your time using nurse resources. So thank you, Helen. And Lisa, did you want to introduce yourself?
Sure. Good morning, everyone. I'm Lisa, and I'm happy to be here. I'm excited you get started at NERSC. We're here to support you. So, as Charles and Helen and Lippy already said, please send your questions our way, and we're here to help you out getting started.
Awesome. And with that, I would love to allow for Dr. Debbie Bard to take over and start with the Welcome to NERSC presentation.
Good morning, everyone. So let me just put something in the chat real quick. There will be a lot of links in the slides that I'm showing. You can't click on those links through Zoom, so I'm putting them in the chat here for your reference, so you can
And
go to those as you
also,
follow
Debbie,
along.
I put the PDF of the slides in our Q&A document. So everyone for our presentations, you can
Excellent.
access them there too.
Fantastic. All right, good morning, everyone. Welcome to NERSC. My name is Debbie Bard. I'm the department head for science engagement and workflows. So pretty much everyone that you're going to interact with during your time using NERSC is in my department. We have all the kind of user-facing user engagement groups in science engagements and workflows. So I'm here to give you a kind of overview of NERSC, an overview of the systems that we have, a little sneak peek of the system that we're about to procure, and give you an overview of the kind of resources available for you for training and help that you might use while you're using NERSC. But we, as Charles was saying, we strongly encourage you to reach out and take advantage of our expertise. We have a lot of people on staff at NERSC who are extremely experienced in basically everything that you're going to be doing with Perlmutter and with NERSC. And so if you have any questions, if you have any concerns, reach out to us and we'll be able to help. Okay, so I'm going to be spending maybe 25 minutes or so going through this. I have an introduction to NERSC. We'll talk a little bit about the kind of science that happens at NERSC. I'll talk about the hardware at NERSC. I'll go into a few details about that and then how to interact with NERSC staff. So for those of you who are unfamiliar with NERSC, we are the Mission HPC and Data Center for the Department of Energy Office of Science. And the Department of Energy is the largest funder of physical science research in the US. So the range of science that's supported by the Office of Science is really broad. All the way from biological and environmental research, nuclear physics, high energy physics, materials science, fusion science, and of course, advanced computing research. These are all aspects of work funded by the DOE, and any scientist who is funded by the DOE can request time on our systems at NERSC. So that's what it means for us to be the Mission HPC Center, the Mission High Performance Computing Center. And that means that we have an extremely broad user base. We have scientists from every corner of science within the DOE, running all kinds of applications and all kinds of workflows. So our mission is to support science for DOE, but it's also to support the state of the art in supercomputing. And you'll see a little bit of this as I talk about our systems, but we collaborate really closely with computer companies, with our vendors. We work with them years before our systems go on the floor to make sure that we're designing supercomputers that are going to be useful for our scientists. That's really the most important thing for us. We measure our success not in how big our system is, but how well it is used by our scientists and how much science it can produce. That's really the core of our mission. And so to do that, we think very carefully about how users interact with the system. We don't just put a pile of hardware on the floor and give people SSH access. We provide a highly customized software and programming environment for science applications. And we work very closely with scientists who are running all kinds of workflows, simulations, data analysis, but in particularly, we couple closely with other DOE user facilities. Particularly experiment and observational facilities. There are several at Berkeley Lab, including the Advanced Light Source and the Molecular Foundry and the Joint GMOD Institute. We work closely with science teams at these experiment facilities to help them bring their data to us for analysis and combine it with simulations in the kind of complex workflows that scientists are doing today. So this means that we have an extremely broad user base. It's actually now closer to 11,000 users, 11,000 users from institutions all over the United States and all over the world, all people who are working on DOE-sponsored science. And we've been doing this for a long time. Last year was our 50th anniversary. NERSC has been operating since 1974, when it was deployed as a computing center for fusion science specifically. And we actually have in our tape archives data from that period. We never throw anything away. We still have, it's not a lot of data, granted, but we do have data from the 70s still in our archive. Another thing I want to point out here, we have about 11,000 annual users, but if you look at this breakdown in the bottom left, something like half of our users are what we consider early career users. So undergraduate students, graduate students, and postdocs. We have a lot of users who are new to HPC. Something like a quarter of our users every year have never used a supercomputer before. And so we take what we're doing here today very seriously. It's also part of our mission is training the HPC workforce of the future, and training and workforce development. So I mentioned before, for NERSC, we measure success by the depth and the breadth of our scientific impact. And we measure that in a few different ways. But one of the things we're always really proud of is when our work has a big scientific impact. For example, the ways that we contribute to Nobel Prize winning research. This is always very exciting for us when one of our users receives a Nobel Prize. I think there's 6 of our users in the past 20 years have received a Nobel Prize in various fields. The most recent one last year, 2024 Nobel Prize in Chemistry, was awarded to David Baker, who's a researcher at University of Washington, who used AI and Perlmutter to build models to describe and to design new types of proteins. The Nobel Prize was actually awarded for work he did prior to using Perlmutter, but we're still very proud that we support this work and its evolution and the kind of really cool things that they're doing today. The other thing I want to point out, that's a depth of scientific impact, but in terms of breadth, we also keep an eye on how many scientific publications are published with NERSC support. So in the last 5 years, we've been acknowledged in over 11,000 refereed publications, which is that's something that we're incredibly proud of. This is really how what we do here at NERSC, because we want to make an impact, we want to support science, we want to help scientists do the best they can with their data, with their simulations, with their models, and take all that all the way through to publication. A few more examples of the kind of science that our users produce. Some of you may recognize some of this work because I think some of the people in this training have already mentioned they're working in these similar kind of areas. But we support a lot of material scientists, for example. We have scientists working with us who are designing new materials for more efficient solar cells, and also looking at designing membranes for for next generation batteries that can be used in renewable energy, used in fuel cells, used in water purification. And so this is one example of how people are using our systems to do material science simulations. Other types of simulations include looking at Earth system science, so examining the effect of melting land ice on the global sea level, running big ensemble simulations for that, running simulations, for example, all the way out to the sun, and looking at models of what happens and what might cause solar jets, and these coronal jets which produce solar storms of streams of charged particles that go out from the sun and then impinge on us, on Earth. These can produce problems with power grids, they can produce problems with satellite operation. So there's really what sounds like a fairly esoteric study of what's going on in the center of the sun can actually translate into some real life impact and real life engineering for everyday life. We also do support a lot of data analysis, particularly for large experiments. There's an example here for collisions of light, so colliding photons to produce matter and antimatter. And analyzing that data, which is very complex, it's very large scale. You need something like NERSC to do that kind of analysis, compare it to theoretical simulations, and understand what's happening in the physics of the experiments. And then, of course, machine learning and AI. This is something that a lot of people are working on these days. And NERSC has been supporting machine learning and AI workloads for 7 or 8 years now in a really proactive way. We're on the forefront of some of the methods development and particularly the scaling developments for running large-scale AI for science models on our GPU-based systems. So an example we have here is using machine learning to identify galaxies in a large sky survey. So image data, pixel data, analyzing that using machine learning to identify different types of analysis, different types of galaxies, and using that in astronomy and cosmology analysis to understand a little bit more about what's going on in in the universe in a way that is much quicker than having a graduate student look at every image and do a by-eye analysis, and also more accurate than doing a fairly simple statistical analysis. So we're really proud to be part of all these different science areas, and of course we're excited about all the science that everyone in this training is going to be producing as well. So I'm going to talk now about some of the hardware that we have, the hardware that you'll have access to as a NERSC user. So first of all, excuse me, I want to emphasize that one of the things we really focus on is energy efficiency. This is one of the strong directions that computing architecture, in which computing architecture is heading. We've moved in the last sort of 10 years since I started working at NERSC from many core CPU architectures, moving to CPU and GPU nodes, and then moving forward to very highly efficient GPU node architectures. And this is really the only way that we or anyone can provide increased computing power within a reasonable energy budget. And an energy budget is really important. For one thing, it costs a lot of money to run very large systems. But for another, we really think carefully about our environmental impact and how we can, we don't want to be running a lot of simulations looking at the impacts of climate change, while at the same time producing an enormous amount of energy wastage. We have to really think carefully about this. So we have been, one of the roles that we have at NERSC is helping scientists adapt their codes, adapt their application, adapt their workflows to more energy efficient architectures. This is something that not all scientists are supercomputing experts, and nor should they need to be, and so porting a code from a CPU application to a GPU application can be quite challenging if you don't have the experience in the backgrounds to help you to do that. And that's where we can step in. And that's where the training events and the help desk that you have links to in the slides and in the chat here, that can all help you if you have questions in how you move your applications, your workflows to these different types of architectures. Okay, we name our systems after scientists. And so I'll be talking for a little while now about our Perlmutter system. Perlmutter is named after Saul Perlmutter, actually a cosmologist here at Berkeley Lab, who shared the 2011 Nobel Prize in Physics for the discovery of dark energy. This is a name given to a phenomenon that's driving the accelerated expansion of the universe. And one of the reasons why we selected Perlmutter as the name for the system is because the project that produced the work that was awarded this Nobel Prize was really a pioneer in combining large-scale simulations with experiment data analysis to do this kind of groundbreaking research. And that's something that we're seeing more and more scientists doing now, and we're really excited about it. Now, one of the things that Professor Perlmutter stipulated when we asked him if we could use his name for the system is that he didn't want people to have to type out Perlmutter every time they log in. And so you log in with using his first name, saul.nersc.gov. So let's talk a little bit more about Perlmutter. We've got two types of nodes. We've got GPU accelerated nodes, and we have CPU only nodes. So on the GPU nodes, you'll see from this sketch that there's 4 GPUs. These are NVIDIA A100 GPUs connected to an AMD Milan CPU. And they can be operated as one distinct node. They can be connected to other nodes in a MPI or multi-node job, or they can be accessed in slices. So you can access a part of a node depending on which queue, which partition of the system you submit your work to. We also have CPU only nodes. These are dual CPU nodes, dual AMD Milan nodes. So this is what they look like on a blade. And so we combine nodes onto a blade and the blade has all the extra connections. It has the network cards, it has the liquid cooling in the blade. And so that's kind of the architectural piece of how we take a node and turn it into something that we can put in the supercomputer. So on the GPU nodes, we have, on the GPU blades, we have 2 GPU nodes. And on the CPU blades, we have 4 CPU nodes. And then we stack the blades into the server racks sideways, so not sort of horizontally, but vertically. And it looks something like this when you put it all together in these compute racks that contain 64 blades each. So this is what it looks like in diagrammatic form. If you have been or are going on a tour of the machine room, this is what it will look like in real life. And this is Johannes, one of our tour guides, showing you there. And you can see the verticality of the blades here. And you can also see these red and blue cables. That's actually the water cables for the cooling. Blue denotes cold water, red denotes hot water. This is one of the ways that we stay energy efficient and that we don't use too much. We actually have no air conditioning down in the computer room floor. We don't need it. We can cool nearly all of our hardware either through ambient air, because it never gets that hot here. We can use ambient air to do the air cooling, but we use heavily water cooling to cool our big systems, because you can imagine GPUs produce a lot of heat. They're doing a lot of calculations, moving a lot of electrons around. And so we use water cooling as a very efficient way to keep our systems cool without needing to spend a fortune on air conditioning. Okay, so that is not all that is in the Perlmutter system. We don't just have our GPU and CPU nodes. There's a lot more that goes into a supercomputer. And this is also really important. We have slingshot interconnect. This is the network. It's a highly specialized, highly optimized network that connects all the nodes together. This is a proprietary interconnect from our vendors, HPE. And this is also connects our flash Scratch file system. So we have 35 petabytes of Scratch within the supercomputer. And the reason we have this within the supercomputer network is that your compute job running on the compute nodes has very fast, low latency access to the flash file system to do very fast, very high performance. So we have about 3,000 CPU-only nodes, about 1,800 GPU-accelerated nodes. I've already mentioned these are AMD Milan CPUs and NVIDIA A100 GPUs. Also plenty of memory on each node. But then we also connected through a very high-performance Ethernet connection to the local area network, and from that to the wide area network, which is provided by ESNet, which is also based in this building. It's the Energy Sciences Network. It's also another DOE user facility. And ESNet connects pretty much all the DOE national labs, all the major user facilities and many universities. It's an independent internet for science, very high performance. We have about 1,000 gigabit connection to ESNet at the moment. And then through the Ethernet LAN, we also connect to our off-platform storage, which are very high performance, but not as high performance as connecting to the flash storage on the system. But we have much higher capacity of our off-platform storage. So we have our tape archives, we have disk-based common file system, which is referred to as CFS. And you also have your home directory, which is much smaller, but is really easy to access. And then we have other services, which we may get into throughout this training, other services around Spin, which is our Kubernetes platform for edge services. So that was a little bit of a whirlwind tour through Perlmutter and our system. Any questions so far? All right, you can always put the question in chat if anything comes up, and there's all of our experts on the call can help answer questions if you have anything that comes up. All right, so I'm going to now talk a little bit about our next system, Doudna. One of the things that we pay attention to within NERSC is what our users are doing, and I've talked a few times about workflows and more complex workflows and how that's evolving. We've really seen this in the work that our thousands of users have been doing over time. People 10 years ago were doing a lot of simulation and modeling and a bit of experiment data, but we're seeing these things be less separate and more combined. And we're seeing an explosion of AI training, AI inference, and all the different ways that people are using AI to accelerate their simulations as well as to analyze their data. And what we're planning for in the next couple of years is this confluence of all these different types of supercomputing workflows in these very complex scientific workflows that really don't exist outside of scientific computing. This is what kind of makes it exciting to work on the computing architecture side of NERSC, is really understanding how we can translate the newer developments in the computing industry in terms of hardware into something that's really useful and really powerful for science. And we're excited about our next system because we think we're doing some new and interesting things there. So Doudna is going to be designed specifically for complex and integrated workflows. And we recognize all these things. This is the 10th system that NERSC is deployed, so we also refer to it as NERSC 10. But we have really designed it to have this integrated ecosystem that can support this data analysis and real-time interactive feedback between people running models and simulations, and also data analysis. And combining that with big AI models. And we spent a lot of time thinking about this and doing our research and understanding from reports, from talking to users, from doing large-scale requirements gathering, all these things that are changing. And there's some really interesting features in our next system that are responding to that specifically. So we only announced Doudna about 3 weeks ago or so. It's a very recent announcement. So this is new. This is new news. There are new things that are being released all the time in terms of some of the details of the architecture. So stay tuned. There will be more information over the next year. But we're partnering with Dell and with NVIDIA to provide a system that should give a 10x performance over Perlmutter in terms of end-to-end workflow support. It will be an NVIDIA CPU and GPU system, so we'll have the latest Vera Rubin compute nodes in the system when it's delivered. It'll be delivered late 2026, so about a year and a half from now, and will be available to users in early 27, providing everything goes well. We have another very highly specialized and optimized high-speed network within the system, which is the NVIDIA InfiniBand interconnect. We have really nice technology to connect to the outside world. One of the things that we've been really focusing on is storage, and how can we innovate in storage, given that GPUs are getting faster and getting more powerful, but the GPU technology fundamentally isn't really changing. And so we've looked at things like a quality of service storage system, which means that we'll be able to guarantee performance for workflows using this storage system. So have a guaranteed bandwidth, guaranteed IOPS. This is really focused at workflows that are time sensitive, particularly scientists who are at a running experiment. They have a large amount of data that they need to analyze really quickly, perhaps combined with simulations and AI, to get an understanding of how their experiment is performing and to make adjustments in real time on some of these really big, really expensive experiments. And so we've put in features like quality of service for storage and for network that will help with this. We also have workflow environment nodes that will provide all kinds of other services, support Jupyter, cloud native Kubernetes style workflows, databases, data portals, all the kinds of things that we currently support on our Spin platform. We're bringing that closer into the supercomputer on our next platform. Okay, any questions right now about Doudna and NERSC 10?
I have a question.
Yeah.
So will this have shared CPU and GPU memory?
Sorry, say that again.
Will it have shared memory between CPU and GPU or separate memory?
Will it have shared memory? So I can't tell you the details of the memory because the node architecture has not yet been announced by NVIDIA. But I can tell you that if you look at, there exist today Vera Rubin compute nodes. There are early versions of this, earlier models, and you can extrapolate from there. But the nodes will have both CPU and GPUs on the same node, and so they'll interoperate very effectively, I will say.
You spoke about CPU and GPU in terms of Perlmutter. Like I see, like when I write a script, like it asks keywords interactive or regular one.
Sorry, say that again.
When I write the script,
Really loud.
like it asks me, say, keywords interactive GPU or a regular one. So how do I choose between those? Should I choose an interactive GPU or regular one? Like, what's the concept behind it?
Is this covered later in the material today? How the different types of queues and how to
Yes.
the Perlmutter. Okay, well, we're going to come to that later today rather than me try to mangle an explanation. I'll let the experts talk about that in a moment. Also, if you want to put your question in the chat, then they'll be able to answer it right now.
Yeah. One follow-up.
Yeah.
Will the CPU be ARM-based or x86?
So the Vera Rubin compute nodes will have ARM-based CPUs. All right. Okay, so I'm going to now go through how you can interact with NERSC staff and how you can get help and support. First of all, introducing the NERSC user engagement group. You've met a lot of this team already today. In fact, yes, you've already met Lippy and Lisa and Helen and Kelly. We have other experts in the team as well who are really dedicated to supporting our users. We also have a NERSC user group, or NUG. This is the community for NERSC users. It's the source of advice. You can talk to other users about things that you're, problems, questions. It's also a source of feedback. NERSC folk pay attention to what's said within NUG, and it can help influence our decision making. We hold regular teleconferences, regular Zoom meetings, and we also have a Slack channel, and the link for that is in the slides and in the chat here. And you can join the NERSC user group Slack and kind of see what's going on there. We also, as you know, as you are here, we provide a robust training program for users, all the way from new user training like today up to very highly specialized and very high skill level training. Everything we do in terms of training is recorded, is professionally captured, and it's posted to our YouTube channel. And all the slides are also available on our training event webpage, which is also linked in the chat and from the slides. And so you can browse our event archive and look at the trainings that we've already put on, but you can also look at our training calendar and see what is coming up in the future and see if there's anything that you want to join in. Everything is open to all of our users, depending on your interests. Okay, so that's training and documentation. I want to talk a little bit now about consulting and account support, so how you can proactively get help if there's a problem that you're experiencing or if you need some advice. So we have a really broad consulting and account support team. You'll notice this is more people than is in the user engagement group. This is because a lot of people, a lot of staff in my department and outside my department are part of this. We really take our consulting and support seriously, and so we have a lot of experts from around NERSC who volunteer to help and take consulting shifts, and also handle trouble tickets that come in their areas of expertise. So significant number of our staff at NERSC spend their time working directly with users to help solve problems. So what is a help ticket? Well, you can go to help.nersc.gov and it will walk you through the whole process. That's our help portal. You can search, you can open a ticket, you can open a request, or you can look through our technical documentation if you want to kind of hunt through and get started. And so when you click, if you have a problem or you need some support, then you can click on the open ticket link and that'll guide you through the different steps in our service and our platform for how to open a ticket and how to make sure it's routed in the right way for to get help. So simply opening a ticket and saying, help, it doesn't work, isn't that useful for us? We need a little bit of help from you so that we can diagnose the problem effectively. So when you open a ticket, help us to help you by providing some specifics. Sure, what is the problem? What's the machine? What node? What file path? What are you trying to do? When did it happen? What modules did you have loaded? What was your software environment looking like? Did you try anything to fix the problem? Did it work? Did it not work? Have you had to work around it? That also helps us understand, we don't waste our time suggesting things that you've already done. And if it's particularly complex, you want to think about how helping a staff member reproduce the problem. It might be something that they need to run over and over again and hit over and over again in order to diagnose what the problem is. So we have a link for tips for filing a good ticket, and we encourage you to do that because it will make your interactions with us much more productive. It will help us solve your problem much more quickly. So what do you expect from our consulting? Well, we guarantee that our first response, well, we aim for our first response within 4 business hours. And our business hours are 8 till 5, Monday to Friday, not including weekends and not including holidays. So you can also expect us, we'll try to help you resolve your problem, and we'll also keep you appraised of progress. So we'll give you updates as we go along, as we're investigating different things. We have 11,000 users. A lot of those users are trying to do things that don't necessarily fit within our operating structure. People try to use NERSC to do all kinds of things. And even if it isn't something that you think fits within our structure, then we'll still try to help you. We really try to accommodate user needs, no matter what they are. So don't feel restrained from submitting a ticket if you're doing something that you think doesn't quite fit. We'll still probably be able to help you. And we welcome as well through the ticket system any feedback you have, particularly any constructive criticism, anything that we could be doing better. Oops. We also offer user appointments, and this can be an extremely efficient way to solve a problem. You can schedule an appointment through this link to get 30-minute appointments. We have different topics, but really, if you have a deep dive problem that you don't think is going to be efficient to work through in a ticket, schedule an appointment. And NERSC staff will be able to work, we'll be able to get the right experts online with you, and you can really work through a problem in some detail. We also have office hours this summer. We have weekly virtual office hours. This will help you get up and running on Perlmutter. You can bring questions and your own applications, and you'll get one-on-one help with the NERSC staff in the office hours. And there's the schedule of those linked also here and in the chat. Okay, any other questions about our support model, how we can help you? Okay, well then, thank you very much. Welcome to NERSC, welcome to our new user training.